Hey Becca, what are we learning today?
Today, we will be covering the double angle formula. Today we're covering double angle formulas, and we're learning sine, cosine, and tangent of 2 times some angle theta. Each of these identities has their own formula associated with them. Sine of 2 theta equals 2 sine theta cosine theta. Cosine of 2 theta has 3 equivalent identities: cosine squared theta minus sine squared theta, or 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. So all 3 of these identities are equivalent to cosine 2 theta. And tangent 2 theta equals 2 tan theta over 1 minus tan squared theta. So these 3 identities, sine 2 theta, cosine 2 theta, and tangent 2 theta, can be used to prove other trig identities or to solve for angles in equations. So I'm going to go through an example of a proof and a couple equation examples. I wrote the trig identities at the top of the screen so that we can use them for reference in our examples. The first example I'm going to show you is an example of an identity that we have to prove using the double angle formulas. Cosecant 2 theta minus cotangent 2 theta equals tan theta. So we want to prove that the left side equals the right side. So we're just going to deal with the left side to start. Cosecant of an angle is 1 over sine of that same angle, in this case is 2 theta, minus cotangent is cosine over sine, and we keep the angle the same, cosine 2 theta over sine 2 theta. And since we're just dealing with the left-hand side, we're ignoring the right-hand side because we want to see if we can get the left-hand side to look like tangent theta. So if we combine the left-hand side, we have common denominators. So we get 1 minus cosine 2 theta divided by sine 2 theta. And now we can use our double angle formulas to reduce this. Sine of 2 theta only has one identity, so we're going to put that on the bottom. Sine of 2 theta equals 2 sine theta cosine theta. Now we have a couple identities to choose from for cosine 2 theta, but we need this to look like tangent of theta. So we want to eliminate this one term. So we're going to pick the identity that is going to subtract a 1. So we're going to pick the last identity. 1 minus 2 sine squared theta. Because if you see 1 minus 1, we will no longer have a 1 on the top, and we distribute the minus sign to the 2 sine squared theta term, and we're left with a positive 2 sine squared theta over 2 sine theta cosine theta. And now the 2's will cancel. We've got a sine on the bottom and a sine squared on top, so one of the signs will go away, and we're left with sine theta over cosine theta, and that gives us tangent theta, which is the right-hand side. So we've proved it. In this next example, I'm going to show you an equation that we're going to need to use a double angle formula to solve. Cosine of 2x equals sine x. Now, we need to pick the trig identity that we're going to use for cosine 2x. We have 3 to choose from, but we want to use the one that has a sign in it because we have a sign on the right-hand side. So if we have signs on both sides, it might be easier to solve for x. So let's pick the last identity because it has only a sine and not a cosine. So we're going to replace cosine 2x with 1 minus 2 sine squared x equals sine x. And now if we rewrite this to have all of the terms on one side, 0 equals 2 sine squared x plus sine x minus 1. Notice that we added the 2 sine squared x to the right side and we subtracted 1 to the right side. So if you look at this function, we have 2 times a quantity squared plus the quantity minus 1. This is a quadratic equation because we have a quantity squared plus b times quantity plus c. So we can actually factor this just like a quadratic function. 2 sine x and sine x. And we need our numbers to multiply to equal -1. So we've got the minus 1 next to the 2 sine x and the plus 1 next to the sine x, and you can verify this by foiling these two factors and you'll get what we started with. And this whole thing equals 0. So it's only going to equal 0 if this linear factor equals 0 or this factor equals 0. So let's set them both equal to 0. And sine of x plus 1 equals 0. 2 sine x equals 1. If we add the 1, sine of x equals a half. When you divide by 2, there's going to be 2 values on the interval from -pi to pi, which we'll use to report our answer. There's 2 values that make the sign 1/2, and those 2 values are pi over 6 and 5 pi over 6. And over here, sine of x equals -1. There's only one value where we get a -1 for sine, and that value is -pi over 2. So we use the double angle formula right in the beginning here to rearrange this equation into something that we could solve for x, which we found 3 solutions for x. In my last example, I'm going to show you how to verify some double angles. We're going to use the angle theta equals 30 degrees in order to solve for sine, cosine, tangent of 60 degrees, which is simply 2 times 30. So sine of 60 is the same as sine of 2 times 30, where 30 is our theta. So we're going to use the double angle formula, and we get 2 sine of 30 cosine of 30. And if we plug in the values from the unit circle, sine of 30 is 1/2, cosine of 30 is square root of 3 over 2. The 1/2 and the 2 cancel, and we're left with square root of 3 over 2, which is in fact the sine of 60. So we proved that the double angle formula worked for sine. Now we're going to try cosine. Cosine of 60 is the same as cosine of 2 times 30. Now we can choose any one of these identities to use, and they will all work. So let's try the first one. cosine squared theta minus sine squared theta. And our theta is 30. Cosine squared of 30 minus sine squared of 30. Cosine of 30 is square root of 3 over 2, and we're going to square that. Sine of 30 is 1/2, and we're going to square that. If we square this quantity, square the top, square the bottom, we get 3/4 for this one minus 1/4, and we're left with 2/4, which equals 1/2, and that is in fact the cosine of 60. So we verified the double angle formula for cosine. And now we're going to verify the double angle formula for tangent with the same theta, tan of 2 times 30. So if we plug it into our formula, 2 times tan of 30 divided by 1 minus tan of 30 squared. 2 times tangent of 30 is square root of 3 over 3. 1 minus square root of 3 over 3 squared. So now if we reduce this, I'm going to bring it over here. 2 root 3 over 3 is on top, and we're dividing that by 1 minus this quantity squared. We square the top and we square the bottom. 1 minus 3 over 9. So the bottom, the denominator of this fraction is 1 minus 3 over 9, and 3 over 9 is 1/3. So 1 minus 1/3 is 2/3. So we have 2 root 3 over 3 on top and 2/3 on the bottom, so we can flip the denominator and multiply. Our 3's cancel, our 2's cancel, and we're just left with the square root of 3. And from our unit circle, we know that the tangent of 60 is in fact the square root of 3. So you can use the double angle formulas to verify certain angle measures.
Thanks for watching my video on the double angle formula. If you found this video helpful, make sure you give it a like and subscribe because we're posting new videos every Monday and Thursday. See you then!